Good morning, students. Today we are going to discuss the topic image formation by spherical mirror. So before explaining this topic, let me read out what we have written. Each point of an extended object acts like a point source. An infinite number of rays originate from each of these points. To construct ray diagram, it is more convenient to consider only two rays for the sake of clarity of the ray diagram. The intersecting point of these two reflected rays gives the position of the image formed. So you see, if you want to see an object, there must be source. So what source do? Source sends light on the object, and the object comprises of infinite number of points. Now, as the rays falls on the object scattered light. The object scattered light, it means that the infinite number of points, each of these points scattered light. So there are infinite number of rays scattered from the object or the point object, and these rays when falls on our eye, then we can see the image. So to construct ray diagram regarding the image formation, it is not possible to consider all the rays that is scattered by the object, because if we consider all the rays, then the ray diagram will be clumsy, and it is very tough to understand the image formation. So for the simplicity, we wish to consider two rays scattered by the object, and that scattered rays when intersect at the intersecting point, you will get the image. So what rays we will consider to draw the ray diagram, that part we are going to discuss. Now as per convenient, if you consider the number one diagram, a ray starts moving towards the concave mirror or convex mirror parallel to the principal axis. So this one convention basically. So if the rays moves parallel to the principal axis, then after reflection it passes through the focus. And in case of convex mirror, if the rays strikes on the mirror parallel to the principal axis, then after reflection it appears to meet, or it appears to passes through the focus of the mirror. Now number two, as per this one, the reverse one, if a ray passes through the focus, then after reflection it moves parallel to the principal axis. And if a ray passes through the focus or approaches towards the focus or appear to move towards the focus, then after reflection it moves parallel to the principal axis. So these are these two ray diagram basically are the conventions, and these conventions we are going to use to construct the ray diagram. So few more convention. If a ray passes through the center of curvature, then on the same path it moves back, or if the ray appear to move towards the center of curvature, then after reflection it moves back along the same path but in opposite direction. Now why it is moving along the opposite direction? Because you see, this is your center and this is your curved surface. So you can consider circumference to the center, that is the radius of the curved surface. Now radius and circumference are perpendicular to each other. So if a ray falls normally on the reflecting surface, then it retreats back along the same path. So that's why if a ray passes through the center of curvature, then after reflection it moves back along the same path but in opposite direction. Now the third one, from the laws of reflection, if a ray moves at any angle towards the concave mirror or convex mirror, then at the point of incidence you will get a normal, that is nothing but the principal axis. Then after reflection, with the same angle it reflects back. This also same thing here. So the angle of incidence is equal to the angle of reflection. Now these are the conventional ray diagram, and this conventional ray diagram basically used to construct the ray diagram for the image formation. So you see, number 5, object at infinity. So if the object is at infinity, then definitely we draw the incident ray parallel to the principal axis, because parallel seems that object is at infinity. So definitely after reflection it passes through the focus, so the image formed at the focus. So as per the statement which you have written, the intersecting points of these two reflected rays gives the position of the image formed. So the image is formed at the focus. Now object beyond C. So if you place an object beyond C, then what happened basically, we used to consider two ray, one parallel to the principal axis, then after reflection it passes through the focus, and another one is through the center of curvature. So it rotates back along the same path. So these are the two reflected rays, they intersect at this point. So this is the image formation. So as per the statement we have written, the intersecting point of these two reflected rays gives the position of the image formed. So intersecting point of these two reflected, what are the two reflected rays? This one, another one is this one. Incident and reflected same ray. So intersecting point is this one, so the image is formed here. Now if you consider this ray diagram, this is your center of curvature. So again we are considering two rays. One is parallel to the principal axis, and after reflection it passes through the focus, and another one is passes through the focus, and after reflection it parallel to the principal axis. So this is the intersecting point. At that intersecting point the image is formed. The image is formed at the center of curvature. So if the object is at center of curvature, the image is also at the center of curvature. Now this ray, you see, the object is at the focus. So a ray moves parallel to the principal axis, and after reflection it passes through the focus, and another ray it strikes normally on the mirror. So after reflection it moves along the same path, and definitely this point must be the center of curvature. So these two rays are parallel. It means the object is at, and the image is at infinity. So if the object is at focus, the image is at the infinity. So actually innumerable number of rays strikes on the mirror, but for simplicity we wish to consider few rays, and these few rays are nothing but simplified here 2, 3, 4 ray diagram, as well as 1 also, 1, 2, 3, 4. So with this convention we wish to consider two reflected rays, and in some ray diagram we will see instead of 2 they used to consider 3, but not more than 3, and the intersecting point of these rays gives the position of the image. So it's very simple. More we will get in your coming class, and if you have any confusion, I think these things are not new. I think most of you know. So if you have any doubt, please put your doubt. Okay, so this is all about. Thank you.